Hello, this is Lesson 2, Unit 3 from Math for Honors Hints. So you can find this problem that we will be working on in your book on page 224, number 28. So it's starting to talk about complex numbers, and it's saying 3 plus 2i and its conjugate, 3 minus 2i, are roots of the same quadratic equation. So those are complex or imaginary roots. So for part A, you can see it's asking you to use those roots to write them in the factored form. So let's look down here. So you're going to use those roots to write in the factored form, which means that you're going to put this whole root in there and this whole root in there. So you need to be careful of using parentheses and appropriate distributive property with your minus signs. That's all the hint I'm going to give you on that. And then your next step is you're supposed to expand the expression on the left side. So once you get this expression, x minus your root, and you clean it up a little bit, and then you have x minus your other root, you clean that up a little bit, you're using the distributive property all the way out and see what you get. Now, once you get your answer on the left-hand side, you can always double check that you got it right by doing the quadratic formula and making sure that those roots are the roots that you get. So that's your hints for A and B. Now let's look on here for C. So for part C, it says explain why the roots of any quadratic equation with real number coefficients will always be conjugate complex numbers if b squared minus 4ac is less than 0. Well, just because in math we like to have fancy words for things, we call this the discriminant. And it should look familiar to you because it's basically everything that's under the square root sign when you're talking about the quadratic formula. Okay, so here's your friend, the quadratic formula. Notice that the discriminant is everything under the square root sign. So it's asking you why, when that discriminant is less than 0, can I expect conjugate complex roots? So conjugate just means in the form a plus bi and a minus bi. Those are called conjugates. Notice the only thing that changes is the plus sign or the minus sign. So if a and b are negative, it'll still be the same formula or same way of writing those. Okay, and then it's also saying for part D, conversely to part C, use your reasoning to show any pair of complex conjugates. So these are complex conjugates, are roots of a single quadratic equation with real number coefficients. So what it's kind of asking you to do is go back and do the same thing we did here, but using general formulas m plus ni and m minus ni instead of in part A where you had a specific complex number conjugate set of 3 plus 2i and 3 minus 2i. Okay, those should hopefully be enough hints to get you going on that problem.